Okay, how's everybody doing today?
So I'm good. How are you doing today?
Good. Glad to hear it. Does anyone have any questions about the first two homework, uh, like the homework for the first two chapters before I dive into the chapter 3?
Um, no, I just have to turn it in by Wednesday, right?
Yeah.
Okay, then I have no questions.
Cool. And then you guys should all have you can turn it in week 1, the week 1 page on Blackboard. So today we're going to dive into functions and their graphs. So these are some of the goals for talking about this chapter. So obviously we're going to talk about the evaluating of graphs for a function. I briefly mentioned the vertical line test, but if I give you a function, like if I give you the graph of a function, actually using the vertical line test to talk about it. We'll talk about the domain and range, figuring that out from the graph again, and then evaluating where it's increasing, decreasing, trying to figure out the average rate of change. Talking about a few different types of symmetry of graphs, including odd and even functions. Okay. So this right here is a circle. No surprise there, but it is not a graph. So it is a graph. It is not a function. And the reason it's not a function is because I can draw a vertical line that goes through multiple points. So this fails the vertical line test, which means that it has a single x value that maps to 2 different y values. So if you guys remember that from last week, for it to be a function, every x value has to map to only one y value. This maps to 2, so it is not a function. And that's also the vertical line test right there. So this right here, if we have both, like if we're incorporating both of these in, this is not a function because I can draw this guy and it fails the vertical line test. Also, if it fails the vertical line test anywhere, this is not a function. So it doesn't matter that, hey, I can draw a vertical line here that only goes through one point. If I can draw the line anywhere and it fails, then it is not a function. But if I'm only considering the red, or if I'm only considering the blue, then this would be a function because this would only go through one blue point or one red point. Does that make sense?
I think it makes sense.
Cool. And so this red one right here, this is f of x is equal to the square root of x. And this one we'll call g of x is equal to negative square root of x, in case any of you are curious. What about this guy? Is this a function?
It is.
Yeah.
Yeah. Anywhere I draw a vertical line, it's going to pass, right? And I can also write this as f of x is equal to x minus 1, right? Or no, this is going to be 1/2 x minus 1. Cool. What about this guy? So first off, does it pass the vertical line test?
It does.
Yeah. If I draw a line anywhere, I will only go through one point. So passes the vertical line test. Now I'm supposed to evaluate this at these given points. So what happens when I evaluate this at f of -2? Well, I go to the x-axis and I find -2, and I look at what's the y value. So what's the y value here? It's the y value at x equals -2.
0.
0.
Exactly. About f of -1. So I go over here and I find where the graph is on that point, or for that x value. What's the y value?
6.
Exactly. F of 0.
Would that be 4?
And f of 3.
Infinity? Oh, sorry.
Yeah.
8?
Yes, 8. Thank you. Does this make sense to people? So you're just going over on the graph and going up or down. So you find that x value, and then you just check out where is the function value that corresponds to this x value, and then just tell me that y value. Okay, so here's some other useful questions. So what are the intercepts? And where is the function increasing? So what are the x-intercepts?
-2, -1, 0, and 3.
2 negative, or sorry. So it's going to be -2, +1, and
And positive 3.
right? But the x-intercepts are points, not just the x value. So we're gonna have to just change them into points like this. Cool. Does that make sense to people? So I just look at where is the y value equal to 0, or where does it cross the x-axis, and then I just take those x values and like write down those points. So that's going to be that x value, 0. So y-intercepts. So if it's a function, there's only going to be one y-intercept. Otherwise, it would fail the vertical line test at the y-intercept, or at the y-axis. So what is the y-intercept for this guy?
4, right?
Hmm?
Would it be 4?
Yeah. Sorry, it's going to be 0, 4, right? 4 is the y value, but we can't forget that the x value is 0 on the y-intercept. Cool. So we also want to identify where is this function increasing and where is it decreasing. So looking at this function, where is it going to be increasing? This is going to be an interval.
Would it be at -2 to -2 to -1?
Not -2 to -1, although the -1 is right? Because here at -1 is where it switches from being positive, like increasing to negative, to decreasing, right? So we'll have to -1. But hey, over here it's still increasing, right? Over here it's still increasing. If I were to keep drawing this down, it would still be increasing down here.
So negative infinity to -1?
Exactly. And then it starts increasing again over here, right?
But is that 2 to infinity?
So let's
Or is
call that
it-
1.5. I'm not actually positive what the exact value is, but we'll just say around 1.5. To infinity. And then this will be decreasing Where is it decreasing?
It would be decreasing from -1 to -1/2. I meant -1 to 1/2.
To
One
one
and
and
a
a half,
half.
right?
Yeah.
And we'll have all of these with the parentheses instead of the bracket, because at this point it's neither increasing nor decreasing. When it switches, it's neither increasing or decreasing. Does that make sense to people?
It does.
Cool. And does this pass the vertical line test? We already said yes. So we'll add this guy. So you guys want to give 3 points on this graph for me?
0, 0,
Yep.
4, 2,
Not 1, 2.
4, 2,
Oh, 4, 2. Yes,
Yep.
that is good.
and then 10, 3.
What'd you say again?
10, 3.
10, 3. I think that's supposed to be 9, 3. I think that this is where the intersection happens here, and it's just increasing very slowly. And the reason I'm saying that is because this is y equals x squared. Right? So yeah, so if this is, sorry, y squared equals x, right? Opposite. Y squared equals x. So those are 3 points on the graph. And yeah, you can pick infinitely many. You also could have picked something like 9, -3, or 1, -1, right? So infinitely many points, and you can pick some on the lower half too if you want. So is this a function? Why or why not?
No, because it doesn't pass a vertical line test.
Nope. Yeah, exactly. It does not pass the vertical line test. You want to give me a vertical line to draw?
Say that again, sorry.
Just tell me any specific line to draw.
Literally anything on the right side of the graph.
If x is greater than 0, then it will fail the test. So if we just pick x equals 3 there, then that fails the vertical line test. So nice. So what are the intercepts?
Zero, zero.
Exactly. 0, 0 is both the x and y intercepts. So, and we don't talk about this being increasing or decreasing. Why is that? Well,
It's not a function.
yeah, it's not a function, but also just like as x goes out, this is both increasing above and decreasing below. So like that's why it doesn't really make sense for this for you to talk about this being increasing or decreasing. Okay. So this is a graph of a piecewise function. Yeah, it already kind of gives it away that this is a piecewise function. Someone want to give me the equation for this piecewise function?
So for a piecewise function, it would be some along the lines of if x equals -5, it would be the equation of a slope.
Yeah.
Oh.
But it's not just if x equals -5, it'll be x within a range usually. Right?
Okay, so x is greater than or less than or equal to 0, right?
Okay.
And x is greater than or equal to -5.
Yeah, exactly.
Oh, then I guess y will equal 1. Is that right?
Well, now you have to give like the equation that it's equal to in this range. And to do that, you'll just pick 2 points. I would suggest the 2 extreme points, so 0, 0, and this guy, and use those to tell you what the equation is in that range. So first off, what's the slope for that?
-1/5.
Exactly. So we have 1 minus 0. -5 minus 0 is going to be equal to -1/5. So I have 1/5 x. And then what's our plus b?
0, right?
Exactly, because that's our x-intercept, our
So-
y-intercept.
Okay.
So it's just 1/5 x in that range. And then from 0 to what's the next thing?
0 to -4, right? Or -2?
Negative. Yeah.
Pardon me, Professor.
Sure.
For the 0, one is less than or equal to, and then the other is greater than. Is that because we're only including the equals to 0 to one of those equations?
So typically you do only include like you define it using one of these ranges.
Okay, makes sense.
It kind of doesn't matter here as long as it's included in at least one of them, because if I were to do this, they actually don't contradict. They meet here.
Yeah.
Where it becomes an issue and like you actually have to kind of make a bigger decision is if we had something like this, then you would have to say, then like for the first equation, it would be less than or equal to, and then for the second one, it would be just strictly less than.
Yeah, okay.
And so when they agree, you don't have to worry as much, but otherwise you just do it based on which hole is filled in. If hole is filled in, then it's or equal to. If it's not, then does that make sense?
Yep, thank you.
Cool. So what's the equation of this line right here? Well, this right here is 2, -4. So if we just do -4 minus 0 divided by 2 minus 0, it's going to be -2 x, and then I can look at this to get my b again, and it's 0. So it's just -2x. And now finally we'll look at this guy right here. So what's that range?
Would be 2 would be x less than or equal to 2 or greater than or equal to 2,
Yes.
and x less than or equal to 4.
Exactly.
Then
And then we just have to find the equation of this line right here. So this one's a little bit harder, but should be able to do it still. So we've got 3.
would it be 7/2?
Yeah. So 7/2x. but we do have a plus b this time. Like it's not just 0, right?
Right. So would it just be the first point that becomes the y?
If
Intercept?
you can pick either of them, I would use this one to find the b, right? So if we're just going to plug this into the y minus y naught, then we would have y minus 3, right? Is equal to 7/2 times x minus x naught. So that would be times 4, minus 4, I mean. So we have y minus 3 is equal to 7/2x minus 14. And then we would get y minus 3 is equal to 7/2x. Sorry, y is equal to 7/2x minus 11. Does that make sense to people?
I think I see it.
Wait,
So-
why didn't you just use +3?
Because the equation is y minus y naught is equal to m times x minus x naught. So this is the 3, and this is the 4, but we're subtracting them. Does that make sense?
Yeah.
Okay, cool. So what is the domain and range of this function? What's the domain first? That's the easier one.
-5 to 4.
Exactly. So, and how am I writing that? What are parentheses, brackets, what?
Brackets.
Yes. Because these points are included. Thank you. And then the ranges.
Bracketed -4, bracketed 3.
Yes. Exactly. Because we start off down here, which is -4, go all the way up there to 3. And these are our lowest and highest possible values on this graph. But thank you. Where is this function increasing and where is it decreasing?
Would it be decreasing from -5 to 0 and from 0 to -4 and 0 to -2, 0 to 2 and increasing from 2 to 4?
Okay, so you're saying 0 to 5, or -5 to 0, 0 to 2. So how am I writing these? Are they brackets or parentheses?
They're all brackets.
And then you said that this is increasing.
And bracket to 4.
Okay.
Yeah.
So I think that this one, we're almost right, but it doesn't really make a whole lot of sense to say that it's both increasing and decreasing at this point. At 2, right? So we'll normally just do that as a parentheses. It matters a bit less at the point of -5, but I'll also say that that's a parentheses because it's not quite increasing or decreasing there. It kind of starts decreasing in one direction and kind of just doesn't do anything in the other direction. And then when we have this, well, that kind of just says like that's the same thing as this.
Okay.
As this interval, because we're unioning two intervals that already overlap at this point, right? So so we'll do the same thing for this guy in terms of we'll just change it to parentheses, but the most of the interval inside there is perfectly correct. So, thank you.
Pardon me, Professor.
Sure.
We had written the decreasing initially as a union between the two intervals. If they didn't intersect, but they were both decreasing, would we need to write them as two different areas?
Yeah, so if we had, let's say, this, if that was our graph instead, then we would want for the decreasing to say, we'll actually even just toss that in with a circle there. We would want that to say from -5 to 2 union 4 to 5. So we would need to, like, we would have them, it's decreasing in both of these subintervals. So we'll talk about it for that whole area there. And that union just kind of makes it clear that we're tossing together two different intervals.
Okay. I definitely see what you're saying. That's not exactly what I was referring to. I was more referring to at 0 for x.
Yeah.
If the one goes to 0, but the other goes to, let's say, 11, if they don't meet there, but it's over a continuous x range, if that makes sense.
Okay, so if I were to have something like this,
Yes.
okay, yeah, so as long as it's defined for one of these, so let's say you have this, then I would say, actually, let's just cut it off here so that we've got a clear point. Then I would say you should write this as -5 to 2 in the end. If you wanted to go through that intermediate step of unioning them, then that makes sense. But because it's actually just decreasing on this whole interval, then I would just write it like this, because it will be decreasing on that whole interval, and this is the simplest way of writing that interval.
Okay.
Does that make sense?
Yeah, absolutely. Thank you.
Cool. Okay. So do you guys, someone want to evaluate these 2 points for me?
-2 is 0 and 0 is -4.
Exactly. So we have f of -2, 0, and f of 0 equals -4. Thank you. What about these other 2 points? So f of -3 here.
Would it be 5 and 0? But then again, they have open circles, so I'm unsure.
Yeah, well, actually, exactly. So because they have open circles, they're not defined. But you just identified what are called the limits. So it's approaching those 2 points, or those 2 values, but it doesn't actually get them. So it's not defined at these points, but those are the limits of this function as they approach -3 and 2. Very good.
How would we write that notation out, or is it necessary?
So if it depends on what the question is asking you. So if it says, what is this value, you could say f of -3 is not defined.
Okay, because it's just asking what it equals at that, and it doesn't equal anything. Okay.
Yeah, or undefined. Yeah, exactly. It's just straight up not given any value. But you might have, we won't cover this for a while. we don't talk about limits much in this class, but they're a big thing in calc next term. So limit as x approaches -3 would be equal to 5, right? I think that's what it was, right? Yeah, 5. So this is the notation for, sorry, of f of x. This is the limit. This is the notation for how you would write, oh, this is what the limit is approaching. But if it's just saying what is f -3, then it's undefined.
Okay, thank you.
So what is the domain? And is, so what is the domain for this guy? Well, it's just everywhere this function is defined, right? So it's going to start here at -3 and end here at 2.
Hmm.
But it's not going to include the endpoints. So that answers the next part of that question, which is 3 in the domain and is -3 in the domain. So 3 is not in the domain and -3 is not in the domain. That's one way of writing that something's not in a set, but we could just say 3 is not in the domain. That -3 is not in the domain. Does that make sense to people?
I think it does. So 3 is it's not 3 and 2 are not in the domain because they're open circles.
Exactly. So what about the range? What's the range for this?
Would it be parentheses 5 and parentheses -4? No, parentheses 5 and bracket -4.
Yeah, so -4 to 5, including the -4, because that's values actually reached, but not including the 5 because we can get as close as we want. We can't actually hit 5. Does that make sense to everybody?
Yes, thank you.
Cool. Okay, so is this graph right here a function?
It is.
Yeah, it passes the vertical line test, right? Anywhere I draw a vertical line, we're good. So what's its domain and range?
Bracketed -2 to infinity for the domain.
Exactly. And the range?
-infinity to bracketed 0.
Yes. Thank you. So the domain, it starts off here at -2, and then it can get as big as you want. You can plug in as any number that's bigger, and then it's the y value peaks out at 0, but can get as small as you want, even if it grows very slowly. So about this guy, is this a function?
It is.
Yeah, we can draw the vertical line anywhere we want, and it's all good. What are its domain and range?
The domain would be is that -9 to 8?
I think is -8, right? So
Oh.
6, 7, 8.
Okay, -8, bracket 8.
Yeah, exactly. Thank you. And the range would be?
Bracketed -7, bracketed 6.
Perfect. Because that's our lowest value, and this is our highest value, and the y's are -7 and 6. We have this guy function.
Yes.
I think it is a function.
No, it's not, right? Because the like the end at the bottom and the top goes on like infinitely, so eventually they'll cross. So like, wouldn't the vertical line touch it?
So actually, it's not that they'll both touch, it's that there's no x value at 0.
Oh, okay. Well, it's still not.
Yeah, so it's well, no, it is, because any vertical line we draw has it doesn't have 2 points through it. So this is just a function that is undefined at 0. So it's a function whose domain is a little bit more restricted than we're used to dealing with.
Oh, okay, that makes sense.
Cool. So what
Okay.
what is that domain here?
Would it be negative infinity to positive infinity?
Almost. But remember, we don't have a 0 value, right?
Oh, so would it be negative infinity to, I guess, undefined?
Well, not to undefined, but to 0, right? Union 0 to infinity. Which, because both of these are parentheses, that's saying, hey, 0 is not actually part of it, but we get everything else. Does that make sense?
I think I'm starting to understand.
Okay, because this function is going to be defined for everything other than 0. So what is this? This is going to be so this right here is the function is f of x is equal to 1 over x, right? It's a little bit weird because every 2 markers is the 1 value. So this is saying, okay, this we can plug in any number other than 0, right? And we'll get a valid answer. But if we plug in 0, then we're divided by 0 and that breaks. So we can't put that in. Does that make sense?
Because I think so.
Cool. So what's the range for this?
The
Yep.
same as the domain.
Yes, it is. Exactly. And it's a little bit weird because it's like as you spike off to positive and negative infinity, you get closer and closer to 0, but never actually touch it. And then as you spike off, as x gets to 0, it spikes off to positive and negative infinity. But again, you can't actually reach those values. So we can also talk about the average rate of change over an interval, right? So if we want to calculate the average rate of change between 0, 8 and 1, 4, what would that rate of change be? So we just kind of pretend that these are 2 points on a line, and we would just do that same y1 minus y2 divided by x1 minus x2. So that's 1 minus 0 divided by 4 minus 8 divided by 1 minus 0. So that would just be equal to -4, right? So that would be the average rate of change between these 2 points. Does that make sense to people? We're just finding the slope between these 2 points, and that's like the average rate of change for this function in that interval.
Okay.
So if I were to do this kind of bigger interval right here from x equals 1 to 4, then I would do 4 minus 1, and then I would have 0.5 minus 4. So that would be negative 3.5. 3.5 divided by 3. So that would be yeah, -1 and 1/6. And that is your average rate of change in the interval from x equals 1 to x equals 4 for this function.
Pardon me. How did you go from 3.5 over 3 to 1 and 1/6?
It's a good question. So I just broke it up into 3 and 0.5. Both of them are divided by 3, right? So this goes to 1, and then this goes to, so this is 1/2 divided by 3, so that's equal to 1/6. You don't have to, like, I don't expect you to make the jump to that's 1 in the 6th. I just think that a lot of you guys, like if you were to just put on your test, like -3.5 divided by 3, I would be perfectly happy with this. That would be fine. But I think that a lot of you guys would probably have a bit better of an intuition for what this is than what this is. And then the other option is you could have done the, that's 1.16 repeating, I guess, but if you don't have a calculator, that's a bit harder to do. Does that make sense?
Yeah, thank you.
Sure. So assuming that this plot represents the inventory of store on a given day in thousands of units, what do these average rates of change mean? So if this is like, okay, let's say this is, we're GameStop and we need the PS5s. We get a shipment of 8 on day 1, and this is how many, or 8,000 on day 1. This is how quickly they're selling, right?
I would say that as the day goes on, the demand starts real high because everybody shows up at opening because we have a bunch of PS5s. It starts real high and then gets lower as the day goes on.
Yeah, like that's probably a matter of like, every time Apple releases a new iPhone, there are the people who camp out ahead of time, and they sell a ton on the first day, and then they sell a bunch more on the second day. But the people who really, really wanted it already got it the first few days. The demand slows down, right? So I'm going to call it a day right here, because I went a bit over on the last few days and my voice is kind of starting to give out. So they'll stick around if anyone has any questions that they want to ask, but you're free to go.
Thank you. Have a good day.
You too.
Thank you.
Hey, Professor.
Sure.